All right, we are going to pick up where we left off yesterday with the graphing, so make sure that you have your graphic organizer handy because you need to be able to look at this. This is where the information's coming from that we need. So we finished with number 11, so we're on number 12. So when I look at this equation, I have a plus or minus here, so that puts it in the limison category. So I look at A and B. So A here is less than B. So when I look at that limison column, if A is less than B, that means this is an inner loop limison. Right? My maximum R value. So with the limisons, except for the cardioid, I actually have two numbers. I have a maximum R value, and then I have another R value, which is my smaller one, which is important for my picture. So in this case, it would be the radius of the inner loop. So to get the big one, my maximum R value, I add 2 plus 4, so I get 6. To get the inner loop radius, then I subtract them. 4 minus 2 is 2. For the inner loop limisons, we always have a point on the pole. To get my maximum R value, to know which direction to go, this is sine, so it's on the y-axis. It's positive, so I'm going to go up 6 from here. Then I'm also going to go up 2, because that's where my inner loop is going to be, like right there. So then I also want, so I have basically all the points on my y-axis. I need all the points on my x-axis as well, so that's when theta is 0. So when theta equals 0, I'm going to substitute that in up here. And I get R equals 2 plus 4 times the sine of 0. Sine of 0 is 0, so that all zeroes out. I get R equals 2, and then my point is 2, 0. I could substitute in pi and do the same thing, but I know it's symmetric, so I'm 2 over here. Then that's enough points for me to sketch in my graph, right? So I know that it loops out this way. It's going to dip down here a little bit, then loop around on the inside, and back down here, something like that. Mine's that's a little flat, should probably be a little puffier. Kind of looks like a weird seashell. But that's the basic idea. If we needed it to be more perfect, then we could plot more points, but that's probably all that we need. Okay? All right. Looking at number 13. So this part makes it look like it should be a rose, but there's an R squared here. There's only one that falls in the category of R squared, and that is a lemniscate. Remember that this is A squared, so I have to take the square root of it to get A, which is my maximum R value, which is 4. So a lemniscate looks like a 2-petal rose. This is cosine, so my first petal is on the x-axis. So I'm going to start here. My maximum R is 4. So if I have 1 over here, I'm going to have 1 over here. 1, 2, 3, 4 over here. And it looks like this. If this had been a negative 16, then it would be vertical. Okay. All right, so then I look at number 14. No R squared, so it's not a lemniscate. I don't have a plus or minus, it's not a limison. This falls in the rose category. This is an even number, so I double it to get the number of petals. So this is a 4-petal rose. This is my maximum R value, which is 5. This is a cosine curve, so my first petal is on the x-axis. So here's my first petal. And since there's 4 of them, I think we could probably all agree that we have 1 here, 1 here, 1 here, 1 here. But I'm going to show you how I can come up with the numbers if I didn't know exactly where they were. Kind of like I did with number 11, which 2 pi thirds confused some people. But there's 2 pi goes all the way around the circle, right? I need it split into 4 sections because these have to be evenly spaced. So when I divide that by 4, that gives me pi halves, which means I rotate pi halves to get to the next one, pi halves to get to the next one, pi halves to get to the next one. Again, I understand you wouldn't have to necessarily do all that to know where they go on this one. However, if it was 2 pi thirds, or there was 3 of them, that's why I did what I did on number 11. Okay? So now when I'm going to draw the other ones, I'm looking at this and I'm thinking, they're going to overlap. They're not supposed to. I think I got a little carried away on my pedal here. I'm going to start over. That is one nice thing, oops, about y'all working on Cami. It's easy enough for you to erase just like I just did. Okay, so I'm going to have 1, 2, 3, 4. There we go. Remember, if it was sine, it would have been here, so it would have looked like this. Alrighty, so now I have 5 minus cosine theta, and so there's like a 1 here. It's a plus or minus, so it's a limison. Here, this is A, this is B, so A is greater than B. And even though it's a that negative doesn't have anything to do with A or B either. So I think of that as a positive 5 and a positive 1. So there's 2 where A is actually bigger than B. It's the dimpled limison and the convex limison. If it's a convex limison, then A is greater than or equal to 2B. And 5 is greater than or equal to 2 times 1. So that makes this a convex limison. Remember, I'm getting this from my graphic organizer. I have 2 values on this as well. I have my maximum R value, that's A plus B, that's where I get 6. Then I have the other R value I need, which is subtracting these, 5 minus 1, that is 4. Okay. For a convex limison, I do not have a point on the pole, but from the poles where I'm going to count my 6, I have to figure out which direction. This is cosine, so it's going to be on the x-axis. It's negative, so it's on the negative x-axis. So, oops, I just said I don't have a point, and I accidentally put one. From here, I'm going to count out 6 to the left. Then I do my smaller number to the right. Okay. So the convex limison is the one that kind of looks like a circle, but it's not. So I have all of my x-axis values. Having my y-axis values would help me as well. So I'm going to use theta equals pi halves. So I can get these and figure this out. I'm going to substitute it in up here, so I get r equals 5 minus the cosine of pi halves. Well, the cosine of pi halves is 0, so r equals 5, so my ordered pair is 5 pi halves. So when the angle is pi halves, my radius is 5. I could substitute in 3 pi halves, but the same thing is going to happen because it's symmetric. So there are my points. Remember, it kind of looks like a circle, but it's not, so even if I try to draw a circle, it wouldn't look like a circle. So if you just try to make this thing look circular. Ooh, that's a little flat there. Just doing the best we can. Like so. Okay, there's your convex limison. All right, so then I have r equals 2 theta. There's no sine or cosine there, so that makes this a spiral of Archimedes. There is no maximum r value for this. Now, I wanted to graph one of these with y'all on the notes. You're not going to have to actually graph one on your own. Not that it's that crazy hard or anything. It's just not really necessary right now. But I wanted you to see how it works. So I'm going to rewrite my equation right here so I can scroll a little bit. R equals 2 theta. We're going to make a t-chart. We're going to have theta, and then we're going to come up with our r values. So I'm going to substitute in 0, pi halves, pi, 3 pi halves, and 2 pi. Okay. So when I substitute in 0, 2 times 0 is 0. When I substitute in pi halves right here and multiply it by 2, I get pi. When I substitute pi in here, I get 2 pi. When I substitute 3 pi halves in here, I get 3 pi. Substitute 2 pi in here, I get 4 pi. So on this one, my thetas and my r's are both in terms of pi. Okay, which is going to cause a problem on my my radius because those are not in terms of pi. They're just, numbers. And so look at the scale here. This is 5, 10, 15. So pay attention to that when we go through it. So I'm going to have to estimate, we're just going to go to the nearest tenth to make it easy, estimate my R values with decimals so that I can actually plot some stuff. So pi, we're just going to use that as like 3.1, 2 pi is about 6.3, 3 pi is about 12.6. Oh no, I got off on that. Hang on a second. I skipped one. It is not that. 3 times pi is not 12.6. It's about 9.4. And then this one is about 12.6. Okay, so when I go to graph them, when theta is 0, my radius is 0. When theta is pi halves, my radius is about 3.1. So if this is 5, this is 2.5, 3.1 would be somewhere right about there. Then when my theta is pi, my radius is about 6.3. So here's 5, 6.3, I don't know, somewhere right about there. Then when my angle is 3 pi halves, my radius is about 9.4, which would be right about there. When my angle is 2 pi, my radius is about 12.6, which would be right about there. Okay. So then my spiral is going to come out, look kind of like this. And there's your spiral. But always, always a whole lot better than whatever I draw. All right, so let's look at 17. I'm back to r squared, so that makes it a lemniscate. My maximum r value, this is a squared, so I take the square root and I get 3. All right, so if it is like a 2-petal rose, if it was cosine, we would start on the x-axis, but it's sine, so I start in the first quadrant. And where on the 3-petal rose, I wasn't confident exactly where it would go. I am confident on this one, because if it's a lemniscate, it's going to be at pi fourths. Okay, so this is 1, 2, 3 is my maximum r value, so that's my first petal. And then over here, 1, 2, 3, that's my next petal. All right. If this was a negative 9, then it would look like this. It'll be over there. Okay. All right, one more. Okay, so plus or minus again, which makes it another limison. So A here is greater than B. So again, it could either be a convex or a dimpled. So if it's a convex, that means A is greater than or equal to 2B. That's not what's happening here. So this is a dimpled limison. So I have 2 r values I'm concerned with. My actual maximum r value, I add these 2 together and I get 5. The other one I need, I subtract the 2 and I get 1. Okay. For a dimpled limison, I don't have a point at the pole again, but I'm going to start counting from here. This is sine and it's positive, so I count up 5. That's my maximum r value. Then from the pole, I go down 1. So then I also need basically my x-axis value, so that's when theta equals 0. I'm going to substitute this in. R equals 3 plus 2 times the sine of 0. Oops, I guess I didn't need parentheses there. Doesn't really matter, but sine of 0. So sine of 0 is 0. That means R equals 3. My point is 3, 0. There we go. I also have a pi. That would be 3. So those are the points I need. Then I'm going to sketch it in. Remember, the dimpled limison looks like a cardioid that's starting to pull away from the pole. So it still kind of has a heart shape, but it doesn't point at all. So something kind of like that. But always better. Mine's super lopsided, but hopefully you get the idea. I probably made it worse. Okay, there you go.